layer 2 switching. In layer 2 switching, we saw initially the MAC flooding attack. The mitigation is port security. Then we saw VLAN hopping attack. Mitigation is simple. Put switch port mode access. And we saw various man-in-the-middle attack like DHCP snooping, dynamic ARP inspection, IP source guard, and some more. Now we are into STP related attacks and securing our switches from STP based attacks. Describing STP security mechanism. You see. Switches send a special packet called BPDU. BPDU stands for Bridge Protocol Data Unit. So BPDUs are important, very important for STP to find out if there is going to be a loop. Only with the help of BPDU, STP does this, preventing loop. STP can do prevention of loop by listening to BPDU packets, which are sent every 2 seconds via every port from all switches. But there are some attackers who uses this BPDU to confuse our network, to confuse our STP, spanning tree protocol. If STP is confused, then loop will be there. That's what the attacker wants. He wants your network to go down. Some attackers wants to steal data, some attacker wants to simply spoil our network. So this attacker intention is to spoil our network. So he may add a switch or a switch like software on a computer, a switch like software. It's actually a computer, but it will send BPDUs. But we all know switches only will send BPDU. But this attacker wants to spoil our network. So he has connected a computer, but the computer is pretending to be a switch. The computer is sending BPDUs, which is not normal. The reason for sending BPDU is to confuse our network, confuse STP, so that there will be loop. So confusing with BPDU can be prevented by enabling port fast. Port fast enabled ports don't expect BPDUs, means BPDU replies for any decision making. See, BPDUs are important to prevent loop, but BPDUs are not expected on the access ports. BPDUs are expected only on those ports that connects to another switch. Only switches can send, I told you. Only switches can send video. So when you enable port fast on the ports where computers are connected, port fast is a feature. When you configure that port fast on the ports where the PCs are connected, those ports will not expect any BPDU on the port. If BPDU comes, the port is not going to really listen to it. So enabling port fast is one way to protect. Port fast do not enable between switches, enable only on the access ports. We also have two more to protect us from this type of BPD. One is BPD guard, another one is BPD filter. We can also enable BPD guard along with port fast, or without port fast you can have BPD guard. What does BPD guard do? If any BPDU tries to come in, it will not allow. It won't allow the BPDU to enter. Immediately it will shut down the port if BPDU comes on the BPD guard enabled port. That prevents loop. That prevents rogue BPDU coming in. BPDU filter is similar to BPDU guard, but the difference is BPDU filter will simply ignore the BPDUs coming in, whereas BPDU guard will shut down the port. BPDU guard will shut down the port if BPDU enters, whereas BPDU filter will simply ignore by default. You can also set some specific action what to do if BPDU comes, but usually we don't do that. We just leave it default because we have BPD guard to shut down. If you don't like port to be shutting down, you can enable BPD filter. So these three features, port fast, BPD guard and BPD filter, helps to protect our network that can be confused by rogue BPDUs. BPDU stands for Bridge Protocol Data Unit. They are tiny packets that are sent between the switches every 2 seconds. These packets are the reason behind preventing loop. So between the switches, these BPDUs are really appreciated, but not from a computer. If a computer sends BPDU, then there is an attack. To identify and to mitigate, we use port fast and enable port fast BPDs are not expected on the port. When you enable BPD guard, if BPD enters, it is going to shut down the port. BPD filter, if BPD comes, it won't allow BPDUs to enter. It will simply filter, but keep the port up for other traffics. This is the command to enable BPDU guard. You see, in the global mode, you type spanning tree port fast BPDU guard. See, port fast and BPDU guard works together. So all the access ports will be now enabled by this BPD guard. See, you don't need to go under the interface and do it. When you say spanning tree port fast BPD guard, all the port fast enabled interface will be having BPD guard. Where do you enable port fast? On the access ports. The ports where the end devices are connected, not on the port where switches connected. To verify, we type show spanning tree. Summary total, you can see that BPD guard is enabled. And in VLAN, you can see the forwarding and STP activity. It's okay. This is what important. If you want to enable BPD filter, it is again going to work with port fast spanning tree, port fast BPD filter. Then it shows that the port fast is enabled. BPD filter is also enabled. So what we have seen is how to prevent confusion in network caused by BPDUs. Port fast with BPD guard or port fast with BPD filter is a solution. Now, again, there are some chances for confusing our network with same BPDU. You see, this is our actual root switch. Root switch is a switch which is acting as a point of reference for all other switches. Now, attacker wants to make this switch as the root switch because he don't want the blocking port here. He wants the blocking port to be here. So he wants to confuse the network, and he wants the blocking port to be shifted from here to there. So what he does is he sends a superior BPDU. Listen, I told you root switch is a point of reference for all other switches. Root switch is a point of reference, meaning all traffic will pass through the root switch. And it is this switch, the genuine legitimate root switch. But attacker wants his switch to be the point of reference. He wants to be a root so that all traffic will go through this. For that, he has to shift this blocking port. He has shifted it by sending some superior BPDU. What is superior BPDU? The superior BPDU is the BPDU that will win the process, achieve this, what the attacker wants. So based on the BPDU, only the root bridge is selected. If anyone sends better BPDU, then that one becomes the root switch. How to prevent this? There's an attack. Attacker gains to know all the traffic that is passing through the switch by making his own switch as a root switch. Even though it is your own switch, he is connected here. Attacker is an employee connected here. He wants to know all the traffic that goes through the network. So he makes the switch to which he is connected as a root switch. How to prevent it? Enable root guard. We need to enable root guard on this port and on this port. When enable root guard, no superior BPD will be allowed to send. So this will continue to be a root switch. That's the secret. Enable root guard. This is the command: spanning tree guard root. If in case any superior BPD tries to enter, the port from where it is entering will be going to inconsistency state, meaning it won't work. Right? So this is another solution, problem and solution. Right, so this chapter was about BPDU related attacks. BPDU is good, but that same BPDU can be used by an attacker to spoil our network. And we saw how it is possible and what are the ways to mitigate them. There is also something called unidirectional link failure, UDLD actually. Unidirectional link failure detection, UDLD. See, in fiber optics, not on the physical links, not on the Ethernet links, on the fiber optics, there will be one wire to send the traffic, there will be another wire to receive traffic. So there are chances for one of the wire to go down, the other one will be up. In that case, BPD will not be sent on the path where the wire is cut, but the BPDs will be received from the other switch. So there is going to be an abnormality. A switch is receiving BPDU from a direction, but not sending any BPDU in that same direction because the link is failed. This will also cause loop. What is the solution? We need to enable UDLD like this. Wait, here. See the top two lines. UDLD enable. That's all. So if a link failure happens, UDLD can identify that link only has failed, not the switch. So it will still keep the blocking port to maintain the loopless layer 2 network. See, if you have not undergone STP training, it is difficult for you to understand. I have not delivered STP for this batch. I know it is difficult for you, but I'll just finish. Allow me. I'll be teaching STP in proper. By blocking one port, we prevent loop. But if BPD don't come, the switches will think that I need to unblock to prevent loss of data. But the truth is, the link is available, switch is available, only one path, one direction link is gone, so BPD is lost. So the block that is already there because of failure detection protocol should need to be still maintained to prevent loop. For that, we enable UDLD. Secondly, we have loop guard to prevent the loop. If STP fails, see spanning tree protocol prevents loop. If that STP itself fails, only the software STP is failing. So we need to still maintain the block to prevent loop, for which you need to enable loop guard. So you have to enable loop guard on every port, so that even if STP fails, loop can be prevented. Yep. So to enable loop guard, this is the command. UDLD is because of hardware failure, meaning a fiber is cut. Fiber is cut. This is because of software failure. Here is the command to show that shows how to enable UDLD and fiber optics as well as non-fiber optics. And this is the command to enable loop guard. Guard loop. This shows the difference between the loop guard and the UDLD. The main difference is loop guard and UDLD. UDLD is miswiring, you see. Cable issues, hardware issues. UDLD is STP failure, not the hardware. Securing a network switches disable CDP. We all learned what is CDP. Cisco Discovery Protocol is to discover the other devices. But if it is in a wrong hand, if CDP is used by attacker, they will invent our device. They will be discovering our device and they will attack us. So wherever is not necessary, you need to disable. Also, enable a secret password instead of simple password. Enable an encrypted password. That's what the secret means. For telnet, you use enable secret password, which will encrypt like this. Also, you can also write an access list to say which network can telnet, from which network can telnet. This is the command to do it. You need to do this lab and see, only then you'll understand. I'll teach you in a separate day these things in detail, STP and then these things. So the good practices to secure switches: put the system password, physically lock the room and keep, so that no one will enter into the room and change the wirings or configurations. Try to use SSH, not the telnet. If you're using telnet, try to use some secured access like enable password, secured enable password, and so on. Use banners on the router so that if someone mistakenly lands in your network, if mistakenly someone enters into your premises, means your routers or switches, the warning banner will stop them entering in. Syslog are the logs that are generated whenever there is an event happening. So try to enable syslog so that you will be able to monitor the failures that is happening or the attacks that is happening. Securing switch protocol. So trim CDP wherever is possible. I said trim means disable. Spanning tree, how to secure user attacks based on BPDUs. Mitigate compromises through a switch. So through a switch also someone can cause damages. So we have to take a precaution for trunk links. You need to make sure that only a necessary port are left as trunk. Other ports are shut down or configured as access port. Try to shut down all the unused ports or at least leave it as access port. So on. So this entire chapter was about layer 2 security. What is left is we need to do lab on these topics. So whatever is possible, we will do. Other things we will cover the portions like SCP, then we will do. So this topic onwards means whatever I covered today that needs some more um, explanation because you don't know STP in detail. We have not covered in our CCNA training. So this is from CCNP syllabus I delivered. Uh, Before this, all that we covered can be tested. We'll test it in coming days, and then I'll teach STP. Then I'll cover these things. Hope this later